Hello, everyone. I hope you are having a great time. My name is Dinorah Tovar. I'm Google Developer Expert on Android. Most of my time, I'm doing Android development. The other part of my time, I'm fighting product managers and designers, the typical thing of Android development. And the other part is that, oh no, it goes to loading. Oh, now it's frozen. Okay. When the keynote is not responding, you can always force a close, so don't worry, it's fine. We will do it again. So I was saying that I ended up fighting with the product managers and the designers, the typical. And the other part of my time, I'm doing tweets on Twitter, mostly memes. But I want to give you a little bit of context of how this talk, why this talk has an enormously name. The thing is, this talk is about design systems, mostly because a couple of weeks ago, months ago, to be honest, I ended up tweeting this. It blew up a little bit. It wasn't intentional, but my friends ended up criticizing, saying that I dropped this without a context. So here it is, Zach. This is the context. So let's start. Because this talk actually is about the learnings that can help you to migrate your app to Compose. And to be honest, not your app. That's a little complicated, to be honest. But migrate your design system. Just to see, how many of you are working on a design system right now? Okay, a little bit. Who are doing Compose right now? Okay, that's cool. So this talk, if you don't have a design system, and if you are not using Compose yet, this will help you. So let's go, because this talk is long, guys. So first things first, a good design system can save you many difficult hours. You hear it first here. Your designers are going to tell you that it's cool because they are already using it on Figma probably, or in Sketch. They probably are already using it. But trust me in this one. Your developers, your productivity, you are sitting here, your productivity is going to skyrocket to the sky if you start doing a design system, a proper design system. So first things first, this talk is based on Compose. So we are not going to see a lot of things that are happening on XML. Long live Compose is the new queen. Okay, we do it. So for Compose, there is an approach we need to decide. And this approach we need to decide is how we want to create a new design system. There are many ways to do it. I'm not going to cover all of them in this talk, but you can use material design. That's fine. Everybody loves material design. Some people say it looks a little bit googly. It's fine. It's fine. You can extend material design. Use the components that material design already has to give yourself a push-up to your own design system of your own components. Make it look like your company, like your branding, etc., etc., etc. Or you can make yourself comfortable, brace yourself, and create your own design system, because to be honest, it's really straightforward and it's really easy. You are not going to believe it, but it's going to be easy. So we are not going to cover all. We're going to focus on extends material design. Probably you are already using material design, or maybe using it for some parts. You are doing a theme, you are doing maybe some colors here, etc., etc. At the end of the day, you are using button material design, outline text field, or something like that. If you are already using it, this is going to be the focus of today. But if you want to see something more deep about custom design system in Compose, what you can do is go to my Ryan Harder talk. My friend Ryan Harder has one of the most amazing talks I have ever seen. This is how Dropbox decide to do their material design from scratch. They are not using material design. They are not using any components. It's really cool. Give it a go look. It's on Chicago. It's going to be on Chicago Reboto. He's not here today, but it's cool. If you want to do it, it's cool because it's not that hard. I thought it was going to be harder. First, I want to start with something really cool. Design systems are about discipline. And when I say about discipline, it's because they have a couple of things that we need to address when we are trying to create a design system. The first thing is that we have rules, we have style guides, and we have pattern guides, okay? So the first part of the rules are the design principles. Why are we doing this? The documentation, the language, the design tokens. We are going to talk about a little bit about design tokens because I think Compose do it pretty much amazing, more than XMLs, to be honest. And we have the style guide that are the typographies, the colors, the font sizes, etc., etc. Your designers, if they already have this, they are really happy with it because they use only some type of big icon, some type of typography. We are not mescling everything and just join it, they work at the end. No. We are doing very disciplined design. And we have the other patterns, the buttons, the button navigation, the dialogues, the carousels, everything that your user interacts, okay? So this represents discipline. If you found a little part in here, when you see my mouse, that's a design system. If you can complete all that part, that's a design system. That's how you found it. So to create a design system, first, we need to talk about the components that goes from the smallest thing to the biggest of the things. First, we are going to be talking about the token. A token, it can be pretty much a name, a reference that we use to communicate with our designers, with our marketing team, with our Android developers, with our iOS developers. Usually is one token. For example, a color. This color today is a token. So remember, that color, that pretty nice purpley color is our token of today. It's going to be in this talk a lot. And then we have an atom. An atom is how we can use that little color to put it inside something really cool. Maybe a button, maybe an outline text field, maybe a label, etc., etc. Then we have a molecule. The molecule is how we join things with the atoms and the tokens. And finally, we have a template. A template are the things that you want to reuse. For example, an empty view, a list, a button navigation, how a button interact with the screen. That's a template. Maybe a carousel or something like that, a view pager, something that you reuse over the time, okay? And the language of the atoms and design tokens is quite important because it will give you the same look and feel around your mobile application. Imagine that tomorrow your company is purple, and in the next week, the next quarter is going to be green. Imagine you have to change all these colors just around your mobile application. You want to have just one token. That's the color of the icon, and that's it. That's it. You don't have to do anything else. So the thing, let's review an atom and a token using the example of the purple color, right? So let's see. We usually can have a little object that will have our design colors, the colors that we are going to use around our mobile application. Can be 20, 100, 1 million, whatever you want. But we are going to put it on an object. And we are going to put a name. If you haven't seen Compose yet, this is the way you need to address your colors now. It doesn't exist in the XML anymore. So if you want to go and do a design colors, you need to create this type of object. So we create a color. That primary, that little square that we saw in the other slides, that's the color of here. And this color, we need to use it around our buttons, maybe as an accent, around our mobile application. So when we are creating our color palette for Compose, we need to be addressing some type of principles. And this principle is that we need to create a color palette. This color palette will give us the chance to have a palette that can be used over our templates, over our components. okay? And what we ended up doing for this approach is we create an interface. And inside our interface, there are a couple of variables that you can see have kind of weird names, right? It's a primary default background that maybe it doesn't say a lot to you, but it says a lot to our designers. And we have this variable that calls material colors. And we will go there. And then we have a function that is called light color palette. Inside this function, we use this interface to design which colors we are going to address. Okay? So what we are using in here is that we're using the object that has all our colors and putting a palette, but using our design tokens. We are not using design color.primary in our buttons. We are using primary default background. This will give us the same color around our mobile application. It will make sure that all the colors are the same and that we are addressing the same thing over and over. And if you are using material design, you will see that your design, your material design in Compose has this variable that is material colors. Inside material colors, there's multiple variables that will give you the chance to have different colors that you will be addressing over the time: primary, background, on surface, surface, etc., etc. And you can put all the colors in there. And I want you to see this little guy in here, this variable. Primary default background is actually a design token. It's something that exists in the documentation of your designers, your marketing team, and your mobile engineers from Android, iOS, even web. When we are talking in the day-to-day, in the job we are doing, we say, hey, we are changing the primary default background to this color. And we can just do it. Put it, that's it. All the application, all the website, all the iOS application, the marketing team is now branded with the new color, okay? So tokens are about design decisions, about the specific of the things, how we want to address the things that we want to create, why they are important. And I have a little graphic to show you, because design components are about the value, the variable, the globalization of the token, the alias of the token, and then we can go to the specifics of the component. We go to the generic part, to the specific part, and we make sure that we can do reachability. If we ended up leaving the same function as design colors, just as an object that we can use around our mobile application, we ended up leaving this in the lowest part of this chart. We ended up just addressing the value. And we don't want that. We never want that. It's too generic. If we do that, we are going to have troubles in the future. We want to go to a specific. We want to go to the top of the pyramid. And I want you to take this because the most important thing about a design system is that you can be very specific. You need to be specific. If you are not specific, you are prone to errors. So I didn't do this little chart. It was created by one of our designers in the company I work. So if you want to follow her, she talks about design systems in Twitter. So that's my friend. So now that we see how we can use design tokens and why are they so important, I'm going to show you the fastest way to start using it on your app. It's around 20 lines of code. So brace yourself, because it's going to fit in one slide. So the first thing is that we are going to have a value, an object, and a composable function that we are going to use around our mobile application, okay? Let's see the first part. The first part is the most important part, because this value is called local DLS colors, right? And it's just static composition local of. Static composition local of actually goes to composition local provider. That will give you the chance to take the colors when you are creating a component. Every time you are using composable, it will take the color, it will drop them, and you will be able to use it without having to cause a recomposition, side effect, or things like that, okay? And then what we are going to do is create an object. This object is going to concentrate the colors. In here can be the typography, it can be the shapes, the round corners, etc., that you are going to use in your color palette, okay? So see, there is a value that is called colors, that is going to use design color palette, that was the interface we were seeing before. And inside of here, you are going to see an annotation that is add composable, sorry, I was speaking in Spanish, add read-only composable, that it will give us the chance to have only readable states for the runtime of the composition. And then we are calling the variable when it's current. So every time you want to use it, it will be fine. We are going to do it great. And lastly but not least, we are going to create a scope. If you are using material design to do your composables, you are going to see that there is a material theme. So you ended up using set content and has a lambda, and then material theme. Well, I don't want to use material theme. I have my own colors. I want to do my own thing. So we are going to create a composable function that is going to call it design theme. I just decided that name, sorry. I was not very creative that day. And inside the design theme, you're going to have two functions. Your color palette that is always going to be going default to this palette that we already create. And you can pick if you are going to do a dark theme or not, but I don't have a dark theme, so just the light color palette. And you are going to have a children that is going to be your composable function, or when you are going to put all your composition. And what is going to happen is that every time you go to a composition local provider, you are going to get your colors. And these colors going to be accessible for all the children's inside. Boom. That's it. You have your design system for with colors and typography. That's the only code you need. And obviously, like I was saying, you have set content. Inside this lambda, there is a design theme. And now, inside of this, you can have a constraint layout, for example, and have a background that will go to a reference. But it's not a static reference. It's a composable, local provided reference to that color. Boom, yeah, that's it. You don't need anything else. And you have your content and shalala, you can put whatever you want in here. But yeah, that's the only thing you need for start using your atoms and compose. See how fast it was? So with this, pretty much, I can convert something that our designs are using from a token to an element. And we can start addressing it over our mobile application faster, simpler, and obviously we can create many and multiple atoms that will be focused on respecting that guidelines, that rules, and that styles that our designers pretty much want. So that was only a little breviary, because we are going to talk a little deeper about the atoms, the molecules, and the templates. So for the molecules, these are the complex ones, guys. I'm not going to lie to you. They usually get complicated, especially because you want to still using design tokens around your application. So, for example, you can have your own function of input that will have your edit text, or what it was, an edit text. And inside of here, we have many things. It couldn't never fit the slide. It will be a mess. But we have a function that is an input. It's a composable function. And inside of here, you have modifiers, an input field, a label, a text. You hear the changes of the value when the user starts typing. And we have the transformations, right? Maybe it's a password, maybe it's a credit card, maybe it's an email. You want to have a specific transformation for that. And inside of this composable function, we have a column that has an outline text field. That is, outline text field is a component for material design. So inside of here, we are just extending what material design has and adding the colors that we want. So it looks something like this. To be honest, this is enormous, right? Like, it's bigger than my hand. And it's enormous because it's even bigger in the code. I'm not gonna lie to you guys, it's enormous. And this looks cool, right? This will make sense. If we start doing it, if we start playing around, it will work. But, like I was saying, they become complex and they are prone to errors. If we leave the developers just walking away with this, we will have inputs that are not gonna match styles, maybe inputs that are gonna get lost, inputs that are gonna be a little aligned to the left with that modifier in there. It's gonna be difficult, it's gonna be complex. So what we want to strive for is to have a particular case, a particular use case scenario on our design system. And what we can do, and I'm not saying this is the best approach, because it's not. We need to have inputs that are specific to the things we want to do. So we can encapsulate the information that we want to address and how we want to create it. So before we go to the right approach, we need to review the part of the templates. Templates are pretty much used around Figma. Even Figma has a plugin to create these templates. And mobile engineers, we need to have that also. So we can create components faster. So we can iterate, reuse, and start getting ahead of the things we are doing, right? So remember, at the end of the day, Compose is full 100% Kotlin, so what you can do is create a function that you can reuse and call back to everything you want with the things you need. Just a couple of parameters, don't go crazy in there. That will have just handle the same functionality in the same state that you want to address, and this will make the trick. Try to do it. It will save you a lot of time. And try to make sure that your designers also understand the rules and the guidelines that you are going to use, because the guidelines they have on their documentation should be a representation in code of the things we want to create. That's how we should address it. And now it gets fun. Let's go about abstractions. Because abstractions are actually the use cases and the rules that we want to create on our design system. So, like I was saying, Compose is 100% Kotlin, and that means that this is a function, and Compose also can be a class, and can be an internal variable, and can be static, and can have interfaces, and can have any other stuff, right? So, if Compose can do that, imagine you have this, right? This function. You have some text, and you have a text field, right? And you have a value, and a listener of the value. Every time, if you are not familiar with Compose, every time the value change, we need to make sure that we are addressing the change of the state. So I have a little illustration for that. Imagine you have an input, the user put an input inside, and inside the file, we will have a stage that will change, and it will trigger the rehabilitation of the view, okay? So every time the user click, you will have to listen that stage, and it will change the visualization for the user. So if Compose is Kotlin, then we can create abstractions of the things we want to do, because that example is quite simple, right? It only has a text, and the user is writing. But imagine a very complex form, or a very complex account creation, maybe these kind of forms that are super large, and they are quite complex. It will get very tricky to handle all the states of all the edit text. It will get complex to handle all the validation of your edit text. And you think you can handle it, okay, that's fine. But you might end up with 20 fields in just one function, and it's going to go insane. I promise you, it's going to go insane. It's not the best approach. So what we can do is actually create an abstraction of the things we want to address. And what we can create is a not so generic input field that can handle the states and the validation for us. Can create a transformation, a validation, can give us the hint we want. So if we can provide this to our developers and start using this this way, we might end up having an easy way to create a form. Okay, so inside of here, what you are going to find is that you are going to have a enum class that you will have all the input fields that you want to have, an email, maybe a password, maybe a credit card, etc., etc. And it has these validations that are very specific, that has the hint, the specific hint, the validation of the field when the user is creating, the transformation, and if we have it will have the validator that it will handle if the email is correct with the regex, etc., etc. But it also will handle the state of the mandatory of the form, right? This is how we should be striving to do some components in Compose. If we can do this, we can close and encapsulate the way we want to address some of our components. We don't let the users use input, we force them to use input file. And inside input file, we can decide what are the functionalities around the input file, around the mobile application, around all the process inside a mobile application. And if we get a little creative, we can create abstractions or more complex process. We can create a way to put all our inputs and handle it just by one file insertion, a list, another function that will handle how you are starting to insert. What we can do in here is that we can go and create a list of the enum that we were seeing, that will be generic, that will have some specific approach, and we will start inserting all the elements on runtime to handle all the fields insertion. Ta-da! That's it. You don't need to do anything else. Because remember, Compose is not XMLs. Compose are not data binding. Compose is not views. Compose is Kotlin. So if we can remember that, we can start thinking and approaching our code not as views itself, but as Kotlin itself. And if we can do that, it will be simpler. The third part of this talk is pretty much focused on interoperability. Not everything has to be composable. I know maybe you want to do it, but migrating a mobile application to Compose is not that simple. You have legacy code. Maybe the developer that did that already left the company, and no one knows what is going on in that special view, and that's okay. So Compose has interoperability for multiple things, has support of views, and when we are doing a view, it will look something like this. You will have a binding of the view on the XML, and then you have a composition strategy that will remember to dismiss that binding when the time is right, and you will have the set content, and inside of here, you can put your material team that we already saw. Well, your specific design team that you already saw. And inside your XML, it will look something like this. I don't love it, but it's a great approach if you want to start migrating things a little by little. It helps us a lot, to be honest, because we also have Compose has a full support for fragments. And when you are having a multi-module application, a huge mobile application, it's quite complicated to migrate everything to Compose because you have a new design system. It's not that simple. But what we can do is that we can start keeping using the fragments that we have and just start moving the views. And the fragment will have a compose view, and it will use the same strategy to dismiss the view when it's going on destroy. And you can set the content and put the design team inside of it, okay? And I was in Sumaya's talk about navigation, and inside this talk, she was talking about the navigation component of Compose. And if you want to use navigation component of Compose, you need to make sure all the views you are going to use are composable. If not, you need to use fragments. That's huge, right? If my navigation is not fully composable, I cannot start using a navigation component of Compose. A bummer, isn't it? But it is what it is. And finally, I want to talk about something that you need to be very careful when you are trying your design systems. And the first part is that there are a lot of side effects in Compose, and you need to be very careful of the side effects that you might be causing or the things that you don't want to cause, because this will cause you a recomposition. And you don't want that. Recomposition takes a lot. Usually Compose is very, it wants to be positive about the recomposition. It only picks the element that change. For example, if you have a view that has an image, an edit text, and a button, if the edit text change, the recomposition should only happen on the edit text. But if you are attacking your design system in a complex matter, or maybe you are not doing the proper decisions on your design system, it might be ended up triggering the recomposition of the full screen, right? And abusing the recomposition is something we learn when we start trying to migrate a mobile application. The performance of the mobile application went downhill. I'm not even lying. My teammates are there. They can tell you that the performance was not the best. And the reason it was not the best was because the recomposition was getting abused. Very, very and deeply abused. So you need to make sure that when you are doing the pop-up of your data to your composable function, this will create an emission. It's not just jumping or sending the data. No, it's creating an emission of data. And this will trigger the composition. So if you are doing the example I was telling you, when the user is just clicking on an edit text that is filling out the email or something like that, the first iteration when the user inserts a first letter will trigger a composition. And the second iteration, when they insert the next letter, this will trigger a recomposition. So you don't want to over-abuse this process. You don't want to do that. So the thing about recomposition, going back to the same example, is that if we have this text field, and this view is really simple, it's not going to trigger a recomposition, right? But if the user starts clicking in the letters, the input, we will go try to show the new information in the field, right? And it will go to the input and will be evaluate the text field again. And this is cool. This is fine. This is what we want, right? But this applies in very specific cases, scenarios, when you want to do a change on your view. If you don't want to do a change in your view, you should be optimistic about that recomposition. You should strive for not doing any recomposition if you don't need it. So be careful in here. That's very important in your design system, especially when you are trying to do generation of code, or maybe you want to maybe do some abstractions of the logic you have. You need to be very careful on these steps, especially because you might want to use remember and around your composable. This is just a little simple function And this function is called an view model and is observing a flow, right? So you want to make sure that launch effect is used in the same manner, in the manner that you are only calling view model get something based on the ID once. You don't want them to be just flowing every time you go any change or any recomposition because it will get triggered. You don't want that. It will cause you performance issues and it will not look good. So what we want actually is to have this way trigger just once, okay? But this talk is not about recomposition. But if you want to see more about recomposition, Aida, which is sitting there, he's going to give an incredible talk about recomposition and what it means for your mobile application. So you should go and see her. I think it's tomorrow. So go and see her because it's going to be great. She explains how recomposition works and what it means for your mobile application. So you can pick that learnings and apply it to your design system and how this is, should be addressed. Okay? So my name is Dinorah Tovar, and this was how good design systems are vital in Compose. So thank you so much.